We want to thank Chai for inviting us to the Asilomar Conference, where this talk was first given. We're talking about how value extrapolation can be, maybe somewhat surprisingly, used to solve the perennial problem of AI wireheading. This is a talk by Rebecca Gorman and myself, Stuart Armstrong, working at the startup Aligned AI. This is a simplified model of how wireheading can emerge. Imagine we have an AI tasked with showing news, presenting a news feed to various internet users. We want to encourage the AI to show things that make people happier rather than more anxious or sad. To this end, we snap a photo of the person after they have interacted with the news, and this photo is passed to a independent label, a very simple, dumb system that just assigns whether the person there is happy or sad. And the labeled photo is passed back to the AI with a value judgment on this. We want more of the happiness, less of the sadness. And this is the data on which it is trained and gets its objective. The problem with wireheading happens when the AI can take over this classification neural net with one of its actions. If it can do that, then it can change the label without actually changing anything else. It can assign happy to everything, no matter what the news was originally presented to that person. And in the wireheading situation, this results in it getting maximal accomplishment on every single thing that it does. So it can now write its own success criteria and always meets them. The problem is that the original data does not really distinguish what its objective is. There are many possible features that can distinguish happy people labeled happy and from sad people labeled sad. The label itself distinguishes it. In fact, focusing on this is the wireheading problem. It might be the expression. It might be the physical process generating the label, that simplified classifier that the AI ended up taking over. It might be the underlying emotion generating the expression. Now we're getting closer to something that we as humans might want. It might be some idealized notion of happiness. Now, in the training setting, all of these features are correlated. And while they remain correlated, the AI has no need to distinguish them. As long as the label and the expressions are the same and the underlying emotion is the same, you may as well choose any one of them and just maximize that. It'll all be the same. When the features start to shift independently, either due to change in the environment or the AI's actions, that's when we want the AI to reassess what features informs its decision. This is the reward extrapolation or goal extrapolation, figuring out what it should do in this new environment based on the incomplete information from its training environment and a few key questions. The problem is that the AI might even realize the features are independent until they shift independently. If its only experience of the world is happy photos labeled happy and the same for sad, it might think that these letters are things that spontaneously appear in front of humans based on our expressions or our feelings, or something like that. It has just no need to distinguish until that point. And the features are not generically listed in an independent or human or AI interpretable way. Here, text and facial expressions are things that humans are very good at noticing and disambiguating. But there have been examples in the literature of, say, a AI trained on X-rays of lungs where they were looking for collapsed lungs, where they ended up classifying on the chest drains that were implanted in order to cure that collapsed lung. So this was a feature that was not thought of ahead of time, and yet that we want it to be able to disambiguate upon deployment. As a consequence of this, and especially because human labeling is rare and expensive, the AI must be able to disambiguate features from data that is not human labeled, from the data that it encounters upon deployment. So in a typical example, you would have its training data, and it would draw some line, some hypersurface in high dimensional space that separates these two sets. And for a typical classifier, this is it. You might have a test set and a validation set to check that it got it right, but that is it. And then when an ambiguous image appears, maybe it'll say that this is a happy image. Maybe it'll say it's a sad image. Maybe it'll be uncertain, but that can't be predicted ahead of time. It really just depends on how it has drawn that line. What we actually want it to do when it encounters such an image is to generate multiple hyperplanes, multiple classifications here. In this case, the two most obvious are the sad expression versus happy expression, and the sad label versus happy label. And that it asks itself, or asks the human controller, which of these two perfectly valid classifiers is the one that extends the training data that we gave it. So it asks which classifier, which reward function, which objective is correct on this. Is this a happy image based on the label, or is it a sad image based on the expression? And it is asking to distinguish two classifiers, which may not be human interpretable at all. But fortunately, all that it needs to distinguish those two classifiers here is the correct label on this one image. In general, with multiple ambiguous images and multiple possible classifiers, it will use active learning to figure out the most information in the least queries. Our algorithm that we've developed here is capable of doing this. We will have a paper out soon on this. It is, well, state-of-the-art or beyond state-of-the-art performance. You might feel that this is quite similar to just standard out-of-distribution detection, but it differs in some key ways. Here are 4 out-of-distribution images. And though the first 3 can be out of distribution and might point to a mistake somewhere in the process, they're not ambiguous. It's clear what the label, what the reward is for all of them. They're all happy. So all that you can ask is whether these images are a bit unusual. The 4th one is one of these ambiguous images that has multiple interpretations according to the possible rewards. So this is the moment when it is the most valuable to ask a human. Asking a human is a rare and expensive thing for an AI to do. So this is the moment where you should ask, because the answer provides the most information. It allows not only detection of out of distribution, but given the answer, correction of it, or figuring out whether it should be maximizing the label or the expression. We thank you for listening there, and hope you will be listening to more of our talks in the future, and that AI will successfully get aligned someday. Cheers.